let y is equal to tan x by x 1 by x cube. Okay, so then for this, taking log on both sides, so we get log y is equal to log tan x by x 1 by x cube. So this means 1 by x cube log tan x by x is log tan x by x cube. Taking limit x tends to 0 on both sides, we get, as here in the question we have limit x tends to 0, so we have written limit x tends to 0. So okay, so now that means limit x tends to 0, here we have log y, and here limit x tends to 0, and here we have log tan x by x cube. Okay, so leave as it is. So now we'll perform this right side. Limit x tends to 0 log tan x minus log x by x cube. Okay, so we apply this by log formula, that is log a by b means log a minus log b. Okay, so here it is in the form of 0 by 0 form. Okay, so now log tan x minus log x, so we'll perform the derivation for this both upper and lower part. Okay, so is equal to limit x tends to 0 d log tan x minus, so the derivation of this log tan x is sec square x by tan x minus, and the derivation of this log x is 1 by x, and the derivation of x cube is 3x square. We obtain this output as, we know, d log tan x, we have to perform derivative, so here we have tan x, so we can directly derivate this. So here we get d tan x into d tan x by dx. As you know, we have the formula d log x by dx. Here we have same derivation, so that means 1 by x. Okay, that is like as it. Here we have log tan, here tan, that is 1 by tan x, and the derivation of tan x is sec square x. Okay, so you obtain here sec square x minus tan x by tan. So here again write limit x tends to 0, so multiply this side x sec square x minus tan x by, so here is 3x cube tan x. Okay, as you know, we have x sec square x minus tan x by x tan x by x 3x square. Okay, so this means x sec square x minus tan x by x tan x, in the lower part here we have 1. Okay, so into, so if it goes to the upper side, it becomes 3x square. That means here we multiply and we get this 3x cube tan x. Okay, so now again we have limit x tends to 0. Now we differentiate this term, but here we have two variables, that is x, and here we have trigonometric variable. This is algebraic, this is trigonometric. So we perform for this type of question, we perform is like it, we have xy. Okay, so that means if we have to differentiate this xy with respect to dx, then we can write like this. Here the x dy by dx plus y dx by dx. We perform here multiplication rule. Okay, so like as it is here, we can write so in here we can write x sec square, that is we can write 2x sec square x tan x plus sec square x minus the differentiate of tan x is sec square x, and here in the lower part, here we obtain 3x cube sec square x plus 9x square tan x. Okay, so how we obtain this? We obtain this, so here I will write this. So we obtain this by performing this x sec square x. Okay, so we have to perform this with respect to x, so we can differentiate, like we have to apply multiplication rule. So first of all, here we have the d x and d sec square x with respect to x plus sec square x dx by dx. Okay, so here we have x, and here we cannot directly differentiate this term. Okay, so here we have simple example, that is, suppose here we have dx square by dx, so we cannot directly integrate this term. It performed like this. Okay, dx, that is, so here is 2x, and the differentiation of dx by dx is 1, so that is 2x. Okay, like this here, d sec square x by d sec x into d sec x by dx plus, so sec square x, and the differentiation of this is 1, so that means x. So here it is 2 sec x, and the differentiation of sec x is sec x tan x, so here is sec square x. Okay, we can write like this, so that means sec square x 2 sec square x tan x plus sec square x. We can direct to 0 2x sec square x tan x by 3x square sec square x plus 9x square tan x, so is equal to limit x tends to 0. So here in the upper part we have x, and here in the lower part we can take x is common. Okay, sorry, here it is 3x cube. Okay, here it is 3x cube, so that means 2x sec square x tan x by, take x is common, so here we have x 3x square sec square x plus 9x tan x. Okay, so this cancel out. So here it is limit x tends to 0 sec square x tan x. Here it is 2 and 3x square sec square x plus 9x tan x. Okay, so again we have to differentiate this term. Okay, so 2 sec square x tan x, that is we apply multiplication differentiation. That means so here 2 sec square x tan x. Okay, so take 2 as constant, so here leave it is. So if you have to differentiate, so 2 is in the outside side, so sec square x tan x by dx. So for this 2, so here take tan x d sec square x by dx plus and so here we keep bracket sec square x plus and sec square x plus sec square x d tan x by dx. Okay, so if we write, we can write like this here. So that means 2 tan x and the d sec square x means d sec square x by d sec x into d sec x by dx. That means 2 sec x, and here we have sec x. The differentiation of sec x is sec x tan x. That becomes 2 sec square x tan x. So here remains we have 2 sec square x tan x. Okay, so plus, and here we have sec square x, and again the differentiation of tan x is sec square x. So it becomes 2. So here we have 2 that becomes 4 sec square x. Here we have tan square x plus again here 2 sec power of 4x. So we can write this as 4 sec square x tan square x plus 2 sec power of 4x by again here we have 3x square. So for this here 3x square sec square x plus 9x tan x. Okay, so we'll perform for first of all this. So here we have d x square sec square x by dx. Okay, so it means 3. So here by multiplication differentiation we keep here 3x square d sec square x by d sec x into d sec x by dx plus and here we have sec square x dx square by dx. So we can write this as 3x square. This means 2 sec x, and the differentiation of sec x is sec x tan x plus sec square x. So the differentiation of x square is 2x. Okay, so we can write this as 3 and here 2x square sec square x tan x plus 2x sec square x. So that means we can write 6x square x tan x plus 6x sec square x. So for the first term here we have this. Okay, and for this 9x, so 9x tan x. For 9x tan x we can write like 9x tan x. Okay, that is 9 again here x d tan x by dx plus tan x dx by dx. Okay, so 9. So here is sec x. So here is sec square x. Okay, sec square x plus tan x. So we can write this as 9x sec square x plus tan x. So if we add this and this term, okay, so this is the so the result of this first term is this, and this term is this. Okay, so if we add here it becomes 6x square sec square x tan x plus, so here is 9x sec square x, here is 6x sec square x. So it means it becomes 15x sec square x plus, sorry here it is also 9 tan x. Okay, 9 tan x. Okay, so we can write here 6x square sec square x tan x plus 15x sec square x plus 9 tan x. Okay, as you know sec 0 is equal to 1 and so okay, and tan 0 is 0. Okay, so here if we put limit like x tends to 0, as we obtain the 2 by 0 term, which is not 0 by 0 form or infinity by infinity form. Okay, so if we put the value, so we obtain here 4 sec 0. So if we put sec 0, that is 1, but here tan 0 plus 2.0, sorry here is 1, and again here it is 6.0, and here it is 1 0 plus 15 0 1 plus 9.0. So here we obtain 2 by 0, but we cannot divide any number by 0, so it becomes infinite. So here in the left side we have limit x tends to 0 log y is equal to infinite. Okay, so in the left side we have already this. So now this can be written as log limit x tends to infinite y is equal to e power of infinite. So here it is infinite, so here in the exponential term we have infinite. So this can be written as infinite, sorry here it is 0. Okay, here it is not infinite. So limit x tends to 0 y is equal to infinite. Okay, so as you know the value of a power of infinite is infinite. Okay, so that is limit x tends to 0, here it is tan x by x 1 by x square is equal to infinite. This is the required answer.